So dear students, today we want to discuss exercise 6.2, very interesting, very easy exercise. No one can say this exercise is difficult and triangle chapter is difficult. So the problem given in figure 6.17, these two are the figures. Number 1 and 2 given. 1 and 2 D parallel BC, this is D parallel BC, here also D parallel BC. Find EC from these two measurements given, this one given, EC not given, we have to find EC. And AD from this given, this given, this given, we have to find AD. Now before solving this problem, I recall the definition of basic proportionality theorem. ABC, this is the triangle, and suppose DE parallel BC. If DE parallel BC, then by basic proportionality theorem we get AD by DB equal to AE by EC. We know this formula. If these two lines are parallel and D and E intersect AB at this D point and AC at E point, then if D parallel this, then we get this by this equal to this by this. Their ratios are equal. Now here given DE parallel BC, so solution is start. First we consider number 1. Since DE parallel BC, DE parallel BC in triangle ABC. Since DE parallel BC in triangle ABC, therefore by basic proportionality theorem, we have by basic proportionality theorem we have AD by DB equal to AE by EC. So from this triangle ABC, DE parallel BC, by basic proportionality theorem we get AD by DB, AE by EC. Now putting the ready-made values, AD given 1.5 centimeter, 1.5, and DB given 3, and AE 1 given and EC not given, we have to find EC. So we multiplying EC this side, this one this side, this will be 1.5 into EC equal to 3. Then EC equal to 3 by 1.5. Then if we remove the decimal, we write 10. From denominator we remove the decimal, then we write 10. Then this is 30. Then we get 3, 5, 5, 2. This is 2. Therefore, we get EC equal to 2 centimeter. So this length is 2 centimeter, our answer. This is the answer, EC equal to 2 centimeter. Next we consider this number 2. Now in figure number 2, we have to find AD, DB given, AE given, EC given. We have to find AD. So here, this is number 2, here DB equal to 7.2 cm, AE given 1.8 cm, EC given 5.4 cm. To find AD. From triangle ABC, we have from triangle ABC we have DE parallel BC. So this DE parallel BC. Therefore, by basic proportionality theorem, we have, so what we have by basic proportionality theorem, BPT or Thales theorem, we get AD by DB, this by this equal to this by this, AE by EC. So putting the ready-made values, AD not given, we have to find AD, and DB is given, DB is 7.2, AE is 1.8, EC is 5.4. So this implies AD equal to 1.8 by 5.4 into 7.2. So if we cancelling this, we get 3, and this one cancelling, then we get 3 2 3 4. So we get AD equal to 2.4 cm. This is our answer. AD equal to 2.4 cm. This is the answer, 2.4 cm. So this is solution, very easy solution. Now we consider problem number 2. The two given E and F are points on the sides PQ and PR respectively of a triangle PQR. For each of the following cases, state whether EF parallel QR or not. So these values are given. We have to check whether EF parallel this or not. So the problem given, PQR is a triangle, E and F are the points of PQ and PR. Now some measurements are given whether EF parallel QR or not. If EF parallel QR, then obviously we get this by this equal to this by this. If PE by EQ equal to PF by ER, then obviously these two are parallel. Now we consider problem number 1. This is very easy, very simple. So given, now what are given? PE equal to 3.9 cm, EQ equal to 3 cm, PF equal to 3.6 cm, FR equal to 2.4 cm. Now we check whether this by this equal to this by this or not. Now first we consider first ratio, PE by EQ. PE by EQ, this by this. What is the value of this? PE means 3.9, EQ means 3. So this is 1.3. And next, PF by FR. PF by FR. So what we get? This measurement given 3.6, this is 2.4. If we cancelling by 12, 12 3, 12 2, this is 1.5. So obviously these two are not equal. If this by this not equal to this by this, then they are not parallel. Since PE by EQ not equal to PF by FR, therefore EF not parallel QR. This is not parallel QR because by converse of basic proportionality theorem, these are not parallel. So this is the proof. Answer is no. So answer we get no. This is not parallel. Consider problem number 2. Problem number 2. These measurements are given. Just we rub this same figure. The measurements are different. So the measurements are given. PE given 4 cm, PE 4 cm, and QE given 4.5 cm, and PF 8 cm, and this one 9 cm. Now you want to check whether this by this equal to this by this or not. Just given, what are given? Number 2, given PE equal to 4 cm, QE equal to 4.5 cm, PF equal to 8 cm, and RF equal to 9 cm. These measurements are given. Now, PE by EQ. PE means 4 and EQ means 4.5. So if we remove this decimal, then this will be 40 by 4.5. Cancelling by 5, 5 8s are 40, 5 9s are 45. We get 8 by 9 in left hand side, this side. This by this, 8 by 9 we get. Now on this side we get again PF by FR. PF given 8 and FR is 9. So this CM cancel, we get 8 by 9. So what we get? In left hand side, this by this, and right this by this, same. So since PE by EQ equal to PF by FR, their ratios are equal, therefore EF parallel QR. By converse of basic proportionality theorem, these are parallel. Answer yes. Answer is yes. Now we consider problem number 3. Problem number 3 given PQ equal to 1.28 cm, PR equal to 2.56 cm, PE equal to 0.18 cm, and PF 0.36 cm. Now what are given? If we represent in figure, now what are given? First given PQ, this to this. PQ given, this is 1.28. Next PR. PR means this. PR given 2.56. And this is PE. This given 0.18. And PF given, this is 0.36. So this one given. Now we can directly check this, or this by this we can check this. So this problem we can find first this measurement. What is the measurement of this? EQ equal to we get EQ, this measurement, that means PQ by PE. PQ minus PE. Our requirement EQ means whole minus PE. PQ is 1.28 minus PE is 0.18, and if we subtract this we get 0, and this is 1, and this one 1. We get this one 8, 0, this is 1 and 1.10. And again we have to find FR. FR equal to PR minus PF. PR is 2.56 and PF means 0.36. This is 0, this is 2, this is 2. 0, 2, 2. This one. Now we want to check whether these two are parallel or not. PE by EQ. PE means 0.18 and EQ is 1.10. This is 18 by 110. After 2 digit is decimal, after 2 digit decimal, so decimal cancel, we get this. If we cancelling by 2, 2, 9, that 18, 2, 5, 55. So we get this. 2 5s are 10, 2 5s are 10. Next, PF by FR. PF means 0.36 and FR means 2.20. 2.20. So after 2 digit decimal, here 2 digit decimal is cancelled, 220. Now if we cancelling by 4, 4 9s are 36, 4 5s are 20, 4 5s are 20. So what we get, these two results are same. So what we get, this by this equal to this by this. Since PE by EQ equal to PF by FR. PE by EQ, PF by FR. Therefore, these two are parallel by converse of basic proportional theorem. Therefore, EF parallel QR. EF parallel QR, and answer is yes. These are parallel. Answer yes. This is the answer. So dear students, I think this solution is very easy. These are very simple solution. So main medicine is practice. Without practice, mathematics is very difficult. With practice, mathematics is very easy. So these are geometry. Practice is compulsory. If this solutions is very easy, you are feeling easy, then please like this video, subscribe my channel and click the bell icon. Thank you.